Assalamu alaikum wa rahmatullahi wa barakatuh. Hello guys, how are you getting on? I'm Miss Amira Naggar and my friend, Mr. Habadwini, will be inshallah with you for explaining the math lessons for the first prep. In our math lessons series, we have two branches, algebra and geometry. Algebra and geometry, well, the main branches of the math subject in the preparatory stage. In algebra branch, we have 3 units. The first one, rational numbers. In this lesson, inshallah, you will recognize a new set and revise also the last sets which you have known before. The first one, the counting numbers, which denoted by C and contains all positive numbers starting from 1. And natural numbers, which are denoted by N and contains the 0 and the all positive numbers. And finally, the set of integer numbers, which is denoted by Z and contains 0 and positive numbers and also negative numbers. Let me test your knowledge about this or those sets. We have here a group of numbers and we need to distribute them among the 3 sets: counting numbers, natural numbers, and integer numbers. Okay, could you help me for distributing all of them or classify the all those numbers among the 3 sets? Yes, okay. Let me to start. Or let me begin from the first one. 21 over 7. 21 over 7. I have here a fraction. Which set here I will select for containing this number? No, anyone? Wrong. If you simplify 21 over 7, I will see that 3. So the 3 here will go to C, yes, counting number or natural number or also the integer numbers, because the counting number is subset from the natural numbers and both subsets from also the integer numbers. So the 3 here will go to the counting numbers. 0 will go also into the natural numbers, because the counting numbers set or the set of counting numbers doesn't contain this one or this this number, the 0. Okay, what about the next one? Quarter. Yes, no any set from here can contain this number because it's a fraction. Okay, what about negative 15 over 3? Yes, by simplifying that, it will be the negative 5. And negative 5 is a negative number. And the integer numbers, which the suitable set for contains this number. Okay, what about negative 5, or negative 15? Yes, also in the integer numbers. What about 23? It's one from also the counting numbers. 156 Also, I can put it also in the counting numbers. What about 37%? No, any set here, no, any set here can contain this number or this form. And quarter also, I told you about it before. And here 0.752, the decimal number. No, any set also can contain this number. So keep in mind, please, I have here three forms, all three forms here of numbers, the decimal, fraction, and percent. Can't they I can't put it in any one from those sets, so I have to find another set for containing all those forms. Now let me help you now to recognize a new set which denotes by symbol Q, which is set of rational numbers. In fact, rational numbers or rational comes from ratio. So any number we can written as a ratio, it belongs to this set. Ratio is the comparison of two quantities using division. Also, the Q or the sample Q comes from quotient, and the quotient is the result from the division. So the rational number here, any number I can put on the form a over b, where a and b are integers, and also b doesn't equal 0. Okay, let me to ask you about an important question in this part. How many numbers do you have which can be written on this form a over b? Yes, a huge number of of numbers I can put it in this form a over b, such as the fractions. All the fractions we can, all the fraction which have been written in this form a over b. So because I can't count all those or collect all those fractions in between one set, I will search for a main criteria or main property for describe this set. This criteria will be Q equal A over B when A and B belongs to Q and B doesn't equal 0. Therefore, the fractions, decimals, percentage, and integers, all them belong to Q and also have the same criteria. Let me to give you some examples. Quarta belongs to Q. 88 belongs to Q because 88 is a whole number, but I can put it in the fraction when its denominator equal 1. 88 over 1 belongs to Q. So all whole numbers I can put it in the same form or in its form, and all them also belong to Q. So 37% belongs to Q also because 37% equal 37 divided by 100, which is belong to Q. And finally 0.752 belongs to Q because this decimal equal 752 divided by 1000, which is belongs to Q. But you have to notice that not all decimal numbers I can put it in the fractions. Okay guys, let me back to the main criteria of this one of the set of rational numbers, and let me focus on the b doesn't equal 0. what will be happened if b equals 0? Okay, a over 0 means meaningless or undefined number. Let me give you an example. 6 over 0 equal what? Which number I can, when I multiply it by 0, give me the 6? No, any number. Okay, no, any number. I can find it here. So, undefined means the denominator equals 0. Okay, please notice that. Keep it in mind. Undefined in any question means that the numerator equals 0. Now, guys, let us to find the solution of this example. The rational number x minus 3 over x minus 2 is undefined. If x equals, now I need to find the value of x, which is applied on this to be undefined value. So, if we have found this word undefined in my example, so we have to know the denominator should be equal 0. So x minus 3 over x minus 2, I will take the x minus 2 and it should be equal 0. So the x will be equal to. Now the value of x, so the value of x here should be equal 0 to let this fraction become the undefined value. Let us discuss another idea in this part. In the criteria, and we have focused on b doesn't equal 0, what will be happened if the a equals 0? Okay, any fraction which has the numerator equals 0, the result of this fraction will be also equal 0. So in this example, 0 over 5 equal which number? Okay, which number I can multiply it by 5 to give me the result will be 0. Okay, in this case, the value or that number will be 0. So any fraction will be equal 0 when the numerator equals 0. Okay, please keep it in mind. The fraction will be equal 0 when its numerator equals 0. Okay, in this example, I have the rational number x plus 5 over x plus 3 equals 0. If x equals, okay, if all this fraction equals 0, it means the x plus 5 will be equal 0 to let all the fraction equals 0. So x plus 5 equals 0, which will be x equal negative 5. Let me back again to our previous example, which is about some numbers, or the classification of some numbers. I have here 3 numbers without a set. So I will put now a new set, our new set Q, and let me to ask you about those 3 numbers where I can put 0.752. Yes, it's a decimal, and this decimal I can change it into a fraction by converting it into 752 over 1000. So it will be yes in Q. Excellent. Okay, what about the quarter? Yes, the quarter also is a fraction, and the fraction belong to Q. And what about 37%? Also, I can convert it into a fraction, 37 over 100, so it will be also in the Q. Let me to explain the different forms of the rational numbers. First one, you have to know that rational numbers can be written as a fractions, decimals, or percentages. So all the types of the fractions belong to the rational numbers. Decimal, in the decimals here, the decimal form, we have two types or two types of decimal. The first one, the finite decimal, or it has another name, terminating decimal. Terminating decimal such as 3 over 4, for example, 0.75. That's meaning I have a finite number of digits after the decimal. Another type of the decimal, or another kind of the decimal, which is infinite repeating decimal, or recurring decimal. Recurring decimal, for example, 7 over 11, which is 0.636363, and so on. Now I have two digits after the decimal repeating all the time. So 3, I will write it as 0.63 with dots above the both digits, 6 and 3, which is meaning that those two digits will be repeated. Okay, the last one will be the percentage, which is as in example. Hooray! We have reached now to one of the fantastic or the amazing time. It will be the game time. Put the following rational numbers in the form of percentage. 3 over 4 or 3 quarter equals, yes, 0.75 equals, yes, 75 over 100. So it will be 75%. 1 and 2/5 equals 7 over 5 equals 140 divided by 100. So it will be now so easy to convert it into the percent, 140%. Put the following rational numbers in the form of the infinite repeating decimal. Thirds equal 0.333 and so on, which is equal 0.3 with the dot above recurring digit 3. Sixth, okay, it will be equals 0.16666 and so on. In this case, the 6 is the recurring digit, so it will be 0.1 and 6 with a dot above the recurring digit 6. What will be happen in this question? 2 over 11. It will be equal 0.18, 18, 18, and 18, and so on. So it will be 0.18 with dots above the recurring digits 18. In this question, 3 over 7, the value or the result of this division will be 0.428571 4 to 8571, and so on. 4 to 8571, and so on. How we can write it? How we can write it? By using a new form. Okay, here in this case, we don't add dot above each recurring digit, but only the first digit of the sequence of digits, recurring digits, and the last one. So I will put dot over 4 and 1 only. 4 is the first of sequence and 1 is the last of sequence digits. In this question, 10 over 111, it will be equal 0.09 Okay, and so on. You have to distinguish the recurring sequence digits because here I have 0900900 and so on. It will be here 090. 090 are the recurring digits. So the result will be 0.090 with dots above the zeros recurring digits. Why? Because the zero here, the first zero and the last zero, or the first digit, recurring digit, and the last recurring digit, I don't put the digits above each sequence recurring digit, but only the first and the last digits in this sequence. In this question, express the following number in the fraction form. Okay, to do it, you have to put on the calculator 0.555555 and so on until fill all the screen with 5 recurring digits. After that, press on the fraction button to change it into 1 over 60. Thank you so much for listening, and goodbye.